All right, here we go with lesson 8 for chapter 3. We're actually just going to skip this first part here. It's a little confusing to do without a big group. All right, so we're going to jump right down in here to what we're talking about in this lesson, which is special cases when solving equations. All right, so when we look at this first example here, we'll fill in the blanks, but we're going to solve the equation first. All right, so if we follow the order of the things we're supposed to do, distribute, but there is none with no parentheses, combine like terms, there are none, on the same side of the equal sign. Okay, so we're going to move our variables to the same side. So if I do that here, I will add 4x to both sides. Okay, that leaves me with 12 equals 8x, and then the plus 20 stays. All right, I'm going to go ahead and subtract 20 from both sides, right? I always want to get rid of my constant term first. So that gives me negative 8 over here. And then that's going to equal 8x. And the last step there will be to divide by 8. And I end up finding out that my x equals negative 1. This is the type of equation that we're used to solving, that we've been doing over the last week or so. So when there is one solution, all right, one number will work to make the equation true. Okay, that's what we get the majority of. Okay, but there are special circumstances. So let's slide over here. Same idea, we're skipping some of those beginning steps because we're just trying to get to the point. So if I was solving this equation, I would subtract 3x from both sides to try to move my variables to the same side. But in doing so, what I'm going to notice is a special situation. Okay, I get a 0 where I wanted, but then I also get another 0 on the other side. So I have no more x's to solve for. When that happens, okay, all right, when that happens, I want to observe the result. This is my result right here. Okay, does negative 3, ask myself the question, does negative 3 equal 6? The answer would be no. So that will be a situation where there are no solutions. Okay. So there is no number, all right? There is not a number that will work to make the equation true. And I actually want to write the word no solutions. Okay, special situation when the x's cancel out. And then there's another special situation. Okay, so again, solve the equation first. That's still always going to be the first step, is to do your equation solving steps. All right. Again, when I move my variables, I see that my 2's make a 0, so I'm left with a 7. But again, my 2's on this side make a 0, it leaves me with a 7. Now that statement is a true statement. Okay. So in that scenario, all right, I'm going to have all solutions. That means any number I pick for x would work. And now you'll see that written a couple different ways. All real numbers is the way the book teaches it. Okay, any number would work. All right, you could say all solutions. You'll hear me or see me say infinite solutions. All right, that just means that there's any x value you choose would work for the equation. All right, so you can see down here what they are. Sort of definition-wise, what that looks like, okay? When there's one solution, the variables in the equation through the entire process. If there's no solutions, the variables cancel out, and the result is a false statement. And then if there's all real numbers, that means the variables have canceled out, and the result is a true statement. Okay, let's turn the page and try a couple of examples together. All right, let's see here. Let me blot out some of these that I want you to do on your own. Come back and check those later. And let's do a couple of these together first. Okay, so here we go. Same situation, right? I want to move my variables to the same side. I'm going to do that by adding 5x to both sides. Okay, so I add 5x to both sides. On this side, I'm left with a 13. This makes a big 0. On the other side, also makes a big 0, and I'm left with 13. Does 13 equal 13? And the answer would be yes. All right, so I'm going to say infinite solutions or all solutions. Okay, pretty easy. But when we start adding our steps to equation solving, then, it just takes a little bit longer to get there. So we're going to distribute the 2 first. So I have 13 plus 2x minus 12 equals 4x minus 7. All right, so then I'm going to combine like terms. Remember, don't call me after midnight. So I end up with 2x plus 1 equals 4x minus 7. Now, some of you are sharp enough that you'll figure out when I see my x's are different on each side, then I'm not going to get a special situation. When I move my variables to the same side, that's the next step. Okay, I end up getting 1 equaling 2x minus 7. Nothing special about this problem. Add 7 to both sides. It's my next step. So I end up getting 8 equals 2x. And then I divide by 2. And divide by 2. One of the hardest parts about this type of thing and learning something special is that once we learn something special, we think it's going to apply every time. It does not. This example proves that the majority of the equations we solve are going to be the kind we've been solving, where we have the variable in the process the whole way to the end, and we get one answer. All right, let's try another example, see how this one shapes out. So I'll get 3x by distributing my 1/2 plus 4. On this side, I have 2x plus 4 plus x. I want to combine my like terms. So over here, that's 2x and x, which makes 3x. I did not change the plus 4, and I did not change this side. So again, if you're sharp enough, you would already realize that both those sides of the equal sign say the same thing, right? So it's kind of setting you up for that special circumstance. But if I take another step further and subtract my 3x from both sides, I would end up getting 4 equals 4. Okay, see how both those make zeros. So here's a situation where everything cancels out, and I'm going to say all solutions. So there's a couple of examples. Okay, I want you to go ahead and hit pause, try the other 3, and then come back and check your work. Okay, so you'll notice there we had number 2 gave us infinite solutions. Everything canceled out. A couple more steps to get there, but -7 equals -7 was true. Down here, okay, everything canceled out, but I had 1 equals -4, no solutions. And then over here, okay, everything cancels out again, but 4 does not equal 3, therefore no solutions. And really the big idea here, if you're summarizing this, we're just going to do 7 and 8. Okay, if Anna gets to the end of her problem and she has a true statement, 8 equals 8, that's the situation where we want to say all solutions, right? And then you have the alternative there. Tyler gets -12 equals 12. They do not equal, so that would be a no solutions. And that's sort of the moral of the story today. All right, hopefully you got those notes copied down, and you can move on to doing your lesson 8 homework.